This is more like a valedictory talk after the 3 days of rich scientific output. I have put down some thoughts which have been stirring my mind for some time, and I crave your indulgence if they appear somewhat disjointed. We are going through exceptionally trying times. The coronavirus pandemic has appeared as a global health crisis whose effect is felt in all the countries of the world. It had upset the rhythm of our daily life. Education and research, economic and industrial activities have either stopped or severely slowed down, resulting in disastrous consequences and untold misery to the people. As we pick up the threads again to make a new beginning in the post-COVID world, humanity must address the question of sustainable development and work collectively to make the world more habitable and equitable. Science and rationality is our weapon to chart out the right path in the maze of problems that beset humankind. One welcome development during the pandemic is that science has taken the center stage and public trust in science has somewhat increased. In these difficult times, earth scientists, hydrologists, climatologists, and climate modelers have a challenging role to play, particularly looking ahead to the future. Expertise must be developed utilizing the vast amount of data available globally. Such studies will have great bearings on framing the future global environmental policy and climate policy for sustainable growth. The pandemic has put a brake on our educational and research activities globally. In India, the effect has been particularly severe. However, the situation is somewhat easing now, as indicated by the participation in this conference. As our country gears up to make a new beginning, earth scientists must use this opportunity to thoroughly overhaul the system of earth sciences teaching and research. 15 years ago, Professor P. Balaram, the distinguished biochemist, in an editorial in the journal Current Science, ruled this state of earth sciences in India. I would like to quote his remark to illustrate how earth sciences appear to a discerning scientist from outside our fold. He wrote, "Understanding the science of the earth, oceans and atmosphere must of course be a high priority, and the discipline of physics, chemistry, biology and mathematics must contribute in substantial measure. However, at present the study of earth science in India is at its lowest ebb. Geology as a subject that is taught classically and traditionally in many places, dull, descriptive, and untouched by the excitement of modern science. These courses have few takers. Students come to earth sciences only after many other options have been exhausted. While science courses in universities in general have been struggling, I suspect that the plight of earth sciences is particularly poor." This is end of the quotation. About the state of the research, he also wrote, "A hard look at the output of research in earth sciences," and he uses the word in its broadest sense to cover the atmosphere and the oceans. He says, "will undoubtedly reveal a public record that is limited both in terms of quality and quantity. Most often, the work carried out does not seem in tune with the mainstream activity of the international community of earth scientists. depressed situation of the art sciences in India must be a matter of serious concern in circles which consider science and academic policy. He continued, it is necessary to have a generation of well-informed, thoughtful art scientists who specialize in diverse technical issues. For this to happen, a concerted attempt to revitalize some of our major art science departments and also the starting of new modern programs in some of our best institutions may be a step worth considering. You may or may not agree with his assessment, but nobody would dispute that the redesigning of art science education and research in our country is an urgent necessity. There are isolated islands of excellence, but compared to the size of our country, they are lost in a sea of mediocrity. The present policy allocates a major share of the funds to the so-called central universities and institutes, while the state universities and colleges are neglected. To me, it is doubtful whether this will contribute to the development of science in the country as a whole. The general standard and content of teaching and research in our colleges and universities must make a quantum jump. In the past, several exercises were carried out on all India platforms to improve the curriculum, both in the undergraduate and postgraduate levels. Many of you might have been associated with this endeavor. If we really want to bring about a qualitative transformation, both in teaching and research and of institutional standards, we should introspect why such past endeavors have not yielded much visible result. Without this introspection, I don't think we shall be able to find out where the malady lies. We have to acknowledge, we have to acknowledge that the qualitative changes in university education, in our schools, in our university education cannot be brought about without improving our school education. In the majority of our schools, even in some of the elite schools, the teachers teach for passing the test, instead of assessing whether the students really understand and can internalize what is taught. The students do not get the feeling of the excitement in science. They memorize the text, often without comprehending what it signifies. The mode of teaching does not convey to them the essence of scientific method, that science starts with questioning and builds on logic to explain the observations. The process of learning science in our school does not instill in them a scientific temper that would arm them to face the everyday experiences and the problems of life. I am reminded of the experience of Professor Richard Feynman, the celebrated physicist, while teaching students in Brazil. He found that the Brazilian students could memorize what is in the textbook or what it's taught, but did not understand what they mean. He tells an example that when he asked them about the Brewster angle of light polarization, they could give a perfect answer and could even recite the formula. But when he asked them about the light reflected from the water surface of the bay, which they could see from the window, they had no idea that the light was polarized. The status of science teaching in the majority of our schools is not any better. The teachers have to be sensitized to, so that instead of being purveyors of information, they promote inquiry-based learning and encourage the students to question. The teachers' training programs are to be appropriately strengthened. We should create conditions, and I do not mean only increasing the emoluments of the teachers. That is only a part of it. But create conditions in the schools and in the society that would encourage dedicated, bright students to join the teaching fraternity. This is about science teaching in general. Coming to art sciences, I make a fervent plea to include teaching art sciences as a separate unit like life sciences and physical sciences at the school level, right from the grade where other disciplines of sciences are introduced. The current trend in art sciences is to view the art as a system made up of interacting subsystems of geosphere, hydrosphere, biosphere, and atmosphere that recycle matter and energy from one to the other and even within one domain. The art system science views art processes as part of a system. The aim of the teaching would be to foster this understanding of the art as a dynamic interacting system and to make the students literate about solid earth, oceans, biosphere, and atmosphere. A byproduct would be environmental literacy. Hoffman and Barstow, they have listed 7 items for designing the school education in the art system sciences for the schools in the United States. I'm just mentioning these just to give as an example. The 7 items which they have listed for US schools: art as a dynamic interactive system, space age perspective, 21st century technology, inquiry-based approaches, ocean literacy, atmosphere, weather and climate, environmental literacy. I am not elaborating on these. We may design our own items based on our own priorities. But the concept of art as a system is to be introduced at the elementary stage, and the students should acquire more in-depth knowledge as they advance. Under the sponsorship of the United States National Ocean and Atmosphere Administration, NOAA, and the National Geographical Society, a document outlining the essential principles and fundamental concepts regarding ocean literacy, which is to be taught at schools, has come out. This is easily accessible in the internet. They can be taken as a model, but we can devise our own books. Professional societies like ours, in collaboration with NCERT, can form expert committees to frame similar documents for all the subsystems for Indian schools. However, it is to be emphasized, whatever we do, this is to be emphasized that the 4 subsystems are not to be taught as standalone themes, separately as solid earth, atmosphere, etc., as disconnected and unrelated concepts, but rather in the context of system dynamics, complex interactions, and interconnection between geosphere, hydrosphere, atmosphere, and biosphere. Above all, what is needed, as Orion has remarked, is an attitudinal change towards the exposure of the students to earth system approach and to the development of the system thinking as an integral part of the education for future geoscientists. With the right program, the students can develop high-order thinking skills, such as the ability to discern between an observation, a conclusion, and an assumption, and to think in a geological time dimension, that is deep time, and to engage in spatial thinking, that is thinking about 3-dimensional thinking, and system thinking. New curricula have to be developed, appropriate books are to be prepared, and proper infrastructures are to be built in the schools for web-based access to data and their analysis. And of course, properly trained teachers must be there. University education is to be built on this background knowledge, and the students may pick up one of the 4 domains on which they acquire more profound knowledge in the perspective of the earth as a dynamic, interacting system. Advances in scientific research tools over the past several decades enabled earth system scientists to better understand how complex systems function and to create more accurate models with which to predict a range of system changes resulting from natural interactions and human influences. The undergraduate courses are to be so designed that through them, the students develop this new understanding and approach and gain mastery over the necessary tools, including generating and accessing necessary data, data analysis, sophisticated numerical modeling, etc. The role of the university teacher is to guide the student to think independently and to help him hone his problem-solving ability. Above all, the university department is to function like a community of scholars where each individual cherishes an attitude that respects the intellectual exercises of both himself and of others, and at the same time nurses the value of criticalness towards the intellectual results of anyone. This contributes towards maintaining academic atmosphere conducive to creation and transmission of knowledge. In this context, I must stress on the importance of fieldwork in earth science, training and research. Fieldwork is of vital importance for basic data generation in earth science. Fieldwork is the place, or field is the place, where we observe the interconnection between the different components that make up our study domain. Laboratory study of a sample, no matter how fine, precise, and accurate the data generated are, provides incomplete information unless their interconnections with their native surroundings are known in matching details. Fieldwork is a challenging activity because the student must not only carry out meticulous observations, but also constantly try to relate them to the data already collected and interpret them, drawing on his knowledge of the theory. Hence, field training is to be integrated with classroom teaching and not be a mere appendage and not some hastily arranged half-hearted program. I feel very strongly about this. Fieldwork is not to be merely a field visit, but a session of serious study and training. Technological advances in the last few decades have made a deep impact on how fieldwork may be carried out. Remote sensing, mapping software, and GPS receivers have raised fieldwork to a level much different from our days of hammer, clinometer, and compass. Our students must be trained with the new tools and be adept with them. Unfortunately, fieldwork is often looked down upon as a non-intellectual activity. I admit that I may be prejudiced in my perception, but it appears to me that most of our university departments and the fund disbursers place more importance on acquiring sophisticated instruments than on improving the setup for rigorous field training and provide adequate funding for it. Over the years, the importance of field training has been gradually whittled down. Unless this changes, I am afraid we will not be able to make any seminal contribution to the geological sciences. Apart from the academic role, fieldwork has great cultural impact too. Fieldwork promotes bonding between the teacher and the student. Life in the field camp, sharing the joys and hardships of fieldwork, helps in forging close relationship, often lifelong relationship, between the teacher and the student. The student gets over the inhibition of approaching the teacher, and the teacher has a better appreciation of the strengths and weaknesses of the students and get to know him closely. It is a well-known pedagogic precept that positive teacher-student relationship promotes positive, long-lasting impacts on the students' academic and social development. And closeness between the teachers and the students is important in this respect. But closeness does not grow by granting favors, due or undue, to a student. It grows by developing psychological understanding of and empathy for a student. And the field camp is the ideal place for getting this to know a student closely. The last point that I would like to mention is that there is often a perception among both the scientists and the scientific community that the art sciences lack the rigor and the substance of other disciplines like physics, chemistry, etc. This is to me, it appears to be a totally wrong perception. And art scientists are partly responsible for this in as much as we have not been able to forcefully propagate the challenging aspects of art science and how crucial art science is for the well-being of mankind and for future development. It is true that processes operating in nature are complex and difficult to be quantified. But it is all the more reason why logic, in the case of art sciences, should be more rigorous. Traditional approach in so-called exact sciences is reductionist. This approach often fails in natural systems with complex interaction within and between the different domains, along with the feedback mechanisms. Computer-based numerical modeling has emerged as a powerful tool to study the evolution of complex systems. Again, our professional societies, in collaboration with the national academies, may sponsor expert committees to identify new challenging areas in earth system sciences, covering topics in basic sciences and those with social relevance, like the NSF did for the USA. Inputs from the art science community of India is vital for this exercise. The communities would also look into the infrastructure necessary for carrying out teaching and research in these areas. The focus will naturally have to be on the Indian rock record, the atmosphere and oceans surrounding India. These offer many first-order problems to be addressed, and the Indian scientists must take up the challenge. Let us collectively work to bring about a qualitative change in the art science scenario in our country. Thank you, gentlemen and ladies, for the very patient work. Thank you.